Good afternoon, everyone. My name is Rick Drucker, and I'm the Business Development Specialist for Lessman Instruments Industrial Hygiene and Safety Division. First of all, I'd like to thank you all for joining us for today's webinar on respiratory fit testing, importance, challenges, and solutions. Today's presentation will cover the importance of fit testing and the strengths and limitations of current technologies. We will address common challenges faced every day by both the tester and those being tested, and potential solutions to these challenges. We're super fortunate today to have as our speaker Booth Armstrong, the National Sales Manager of OHD. Booth is a seasoned expert in respiratory fit testing with over a decade of experience in the industry. He is deeply knowledgeable in regulatory compliance, best practices, available solutions, and is skilled in demonstrating fit testing procedures using recognized quantitative technologies such as the QuantiFit 2 and the AeroFit. Booth's expertise spans technical and strategic domains, making him a trusted resource for organizations seeking to build, optimize, or scale their fit testing programs. Excuse me. Booth has helped a wide range of organizations navigate the complexities of respiratory fit testing standards and program management, including some of the most significant fit testing initiatives in the United States. On a housekeeping note, please note that during the seminar, we need to mute everybody's microphone. So if you have any questions, and we encourage them, please just type them into the question and answer box. And I will be sure to, if possible, weave them in or for sure answer them at the end of the session. And with that, I'd like to welcome Booth. Thank him for sharing his time and his expertise with us. Floor is yours, Booth.
Thank you, Rick. I'm glad to join everybody today and super excited about an opportunity to partner with one of our premier partners in Lessman and the team there. We're just very thankful to have that partnership, and I'm excited about providing a presentation on respirator fit testing today. Rick's done a wonderful job of kind of setting the table for us, so I am excited about jumping in. And again, just reiterate, if questions come up, please feel free to hit those into the chat, and we'll either address those as we're rolling through the presentation, or we can address those towards the end. Again, the presentation is on fit testing, respirator fit testing, the importance of it, the challenges that you'll encounter in it, and the solutions that are out there. I think we'd start with the fundamental, just foundational aspect of why do we do a fit test? And it is to protect the health of an employee, and it is to determine that a make, model, and size of a respirator fits an individual's face properly. There's a study that was done in 2009, which is a fascinating study that really lends to the credibility and the importance of the respirator fit test. And that study determined that a poor fit is the largest contributor to poor protection when it comes to respirator wearers. Your other key reasons that we're doing a fit test is to ensure the respiratory protection is effectiveness. That kind of lends to the first point. Prevents workplace exposure to harmful airborne particulates. It builds confidence, morale, and a safety culture among the employees in the corporation, the company, the organization, and it's compliant with your regulatory bodies, whether that's OSHA or any of your other global regulatory bodies, as respirator fit testing is a main part of every regulatory health and safety regulation out there. So lots of important reasons, but none that would overshadow the drive to protect employees as they work in particular environments. Who can do a fit test is a question that we get all the time. And really the base of that question is do you have to have a certificate? Do you have to have some type of certification to oversee a respirator fit test, whether that be a qualitative fit test or a quantitative fit test? Now, if qualitative fit test and quantitative fit test don't make any sense, don't worry, we're going to cover that shortly in the presentation. But those are just different versions of fit test that are recognized by OSHA and your other regulatory bodies globally. The question is who can oversee a fit test? And specifically for OSHA, since we're looking at a predominantly US audience today, OSHA states that someone overseeing a fit test simply has to be confident and competent in overseeing that test, whether they're doing a qualitative test or whether they're doing a quantitative test. They just have to be trained and confident and competent in overseeing that test and utilizing that technology. So there is not a certificate, there is not a certification that's required to oversee a fit test. In many cases, a training on the method and the technology that you're using is all you need to start to oversee a respirator fit test. As you can imagine, after the training, the first number of tests that you do that you oversee is going to be a little bit like learning how to ride a bike. But in my experience, being in this industry for over a decade with a almost exclusive focus on respirator fit testing, once someone's been trained to oversee a fit test with the method and the technology they're using, after they get a couple fit tests under their belt, they're really on their way, feeling comfortable and confident in overseeing those fit tests. All right, next foundational thing would be, when are we going to do a fit test? And there's 2 times that you would initiate a respirator fit test. As a part of the initial respirator selection, so an individual gets hired or a new respirator gets selected, then you would need to do a respirator fit test at that time. The other time when a fit test may be needed is when there's a untested face piece that's already in use. So if you have a company or organization and they have individuals who are wearing respirators and they have not been tested, then that would be a time where we would need to look at implementing a respirator fit test. Obviously, the second note there is typically a rarer situation. The first note is typically the primary time where we see fit testing being implemented, is when a initial respirator selection is being done. The next point would be, when would you repeat a respirator fit test? You would repeat a respirator fit test if the wearer of the respirator loses or gains significant weight that is in the range of around 20 pounds, because we know at that range of weight loss or weight gain, that is going to change the dimensions of their face and would require another respirator fit test to ensure that the make, model, and size respirators is fitting that individual's face and providing the protection that it's intended to. Undergoes any substantial dental work, develops any facial changes, scars around the face or the seal of the respirator. Anything that would change the dimensions of your face would be another time to implement a respirator fit test. The most frequent time you would retest someone is not because of the weight gain or because of a facial change structure. The most frequent is going to be because you've come to the regulated time interval. So again, from an OSHA perspective today, that is on an annual basis. So OSHA's regulations require that a fit test is done on an annual basis. All right, now I want to back up real quick just to kind of put a little bit more detail. As part of the initial respirator selection, I wanted to cover when would you repeat, to kind of give you the whole view of when would you implement a test and when would you repeat a test. But just to back up for just a second, one of the things that we see is unique is when you have a company that is in a make, model respirator, and that company makes a change to a different make and model. That would be a new respirator, And since that new respirator is being implemented in that company, you would have to refit test everybody prior to their annual respirator fit test coming due. So let's just, for examples, let's say you're in a 3M 6000 series respirator and you get tested in January. The company in July switches to the 3M Secure Click or an MSA Advantage or a North respirator or a Clean Space respirator, okay? When you change that respirator, you have not, it's only been 6 months since your initial fit test. But since you changed the respirator make and model, you would be required by the regulations to re-implement the fit test. And then obviously from there, if you kept the same respirator make model, then you would be able to do your regulated retest in July of the next year. So hopefully that doesn't create any confusion and kind of get you a glimpse at some of the unique situations that can happen of when a fit test would be required, either initially or a repeat test. So to say it simply, you have to initiate a fit test anytime there's a new make, model, or size respirator provided, or on an annual basis, or in the rare chances where there's significant weight gain or a change to facial structure. All right, that kind of should give us a little bit of foundation to who can do a fit test, when do we do a fit test, when would we repeat a fit test. So let's go a little bit of a layer deeper now, and let's talk about some of the common challenges that you'll identify or encounter when you're going through the respirator fit testing process. Scheduling and coordinating employees. The thing that I've heard for years is it's like herding cats. Getting all of your people, all of the respirator wearers lined up, getting them scheduled for their initial fit test, making sure you're tracking when they're coming due for their annual test, monitoring for facial changes or weight changes. There's a complexity there that requires attention to detail to make sure that we're scheduling and we're coordinating the respirator fit test for our employees well. The next thing is inconsistent or incorrect testing procedures. We'll see this more with qualitative testing than quantitative testing. And again, if those are new to you, new terms to you, you'll learn more about that in a second. But to give you a quick, brief overview, a qualitative test is overseen by a individual, and they are providing the instructions. A quantitative test is typically it's an instrument, it's a respirator fit testing instrument that's being overseen by a competent and confident individual. When you're doing a quantitative test, the instruments will actually provide you step-by-step guidance on what to do for each portion of the testing process. When you're in a qualitative test, typically it's much more dependent on the operator to lead the test subjects through the process. And when you have operators responsible for leading people through a multi-step process, a lot of times you will bump into inconsistent or incorrect testing procedures. So I think the main note there is if you're doing qualitative testing, it's very important as the operator to make sure that you fully understand what that qualitative testing process includes to make sure you adhere to it well. If you're doing a quantitative test, which is where you have an instrument that's challenging the fit of the respirator, the instrument's going to do a lot of the heavy lifting and walk you through those testing procedures. The next point is respirator training. And what I would really like to call out on this bullet point is the training of how to don and doff a respirator, how to put on a respirator properly and how to take off a respirator properly. One of the number one things that we've determined can impact a respirator Providing the protection it was intended to provide is the wearer's ability to don the respirator properly. Many people do not know how to don a respirator. I completely empathize with the respirator wearer if they have not been trained. Because if you're in a half-face respirator, you haven't determined how to get your nose and chin in the respirator properly. How do you connect the respirator to your face? What is the head harness system? What is the strapping system to make sure the respirator is donned properly? So the thing I would call out most on respirator training is to make sure that you're providing high levels of training on how to don the respirator when you're issuing out the respirator to the employees, because one, that is a key part to a respiratory protection program, is that they know the respirator that they're getting, they know how the respirator they're getting functions, and they really know how to don that respirator properly. The second thing that benefits is when they get into the respirator fit test, it positions them very well to be successful with that respirator fit test, because they can actually don the respirator properly. If someone is not donning the respirator properly, typically it can have a negative impact on your respirator fit test, which is a great time to identify this individual needs more training, needs more familiarization on how to don and manage that respirator properly. Next common challenge that you run into is equipment calibration and maintenance. So on qualitative testing, again, you're not using an instrument. We'll learn more about that in a second. So calibration and maintenance is not really going to impact you if you're doing a qualitative fit test. If you're doing quantitative respirator fit testing, again, that's where you're utilizing an instrument. The OSHA regulation states that you must adhere to the manufacturer's recommendations for calibration. And the fit testing instruments and the fit testing technologies that are recognized by OSHA and the fit testing instruments that are in the market all require an annual calibration. So all of your quantitative respirator fit testing instruments are going to require an annual calibration. And that is a process that at times can create drag and challenges for the organization and the company, because that instrument has to leave the site once a year for an annual basis. How long it's gone is dependent upon the manufacturer of that instrument and what their turnaround time is. One thing that we pride ourselves here at OHD, is quick turnaround time on calibration and maintenance, because we know in most cases, when our customer and Lessman's customer has a fit testing instrument at OHD for its annual calibration, that means that you don't have a fit testing instrument in hand in most cases. So we're very, very intentional to get the instrument back, get the instrument maintenanced, serviced, calibrated, turned around as quick as possible to get you into a place where you're not in downtime without a respirator fit testing instrument. But that is a common challenge that people will navigate, is the annual calibrations that are required for your quantitative respirator fit testing instruments. Next thing, documentation and record keeping. A crucial part of a respirator fit test is the documentation that fit test has been done. Things that the OSHA regs are going to require. We obviously need to know the test subject. We need to know the date of the test, because the date of the test is really going to determine when their next annual fit test is due. We need to know the make, we need to know the model, and we need to know the size of the respirator. We need to know when the instrument last received its annual calibration. They want that on the fit testing report, because it ensures that we have instruments that are within the proper calibration and maintenance period. And then obviously, you would want a breakdown of the scores as they went through the fit testing process and their overall fit factor, their score for that respirator, and if they passed or failed. Okay, so that is what's required, a good overview of what's required for your documentation and record keeping. And you would want one of these fit test reports for each individual, every respirator wearer that you have. Now, if you work for a company that has an individual wearing 2 respirators, like let's say Booth works at OHD, and at OHD, Booth wears a full face respirator for some of his performance for the company, and he wears a half face respirator for other aspects of his job, then I would need 2 different fit tests, and I would need 2 different fit test reports for the different respirators that I've been asked to wear to do my job. So that's a little bit about documentation and record keeping, highly important because it's the backbone to the respirator fit testing program and making sure that your team members and the respirator wearers are in compliance. A question that we get on documentation and record keeping a lot is, how long does OSHA require you to keep a respirator fit test? They actually do not require a historic collection of respirator fit tests. They only require the active fit test. So let's say that at OHD, this is a Scott SCBA. Let's say that I had worked for OHD for the last 10 years. I was fit tested every year in this respirator. OSHA compliance would only require me to have the respirator fit test report for 2025. They just want to know that I'm in an active respirator fit test from this year. Now, the beautiful thing about our instruments and our software is they just collect all the fit test reports because why would we want to get rid of the 10 fit test reports from the previous years I was at OHD? It's beautiful to have that data. So we recommend keeping the fit test reports, but I do want to be clear that OSHA only requires you to have the active report for the year and the time period that we're in. And the last thing that I would want to bring to your attention when it comes to common challenges is addressing hard to fits. And if you've spent time overseeing respirator fit tests, you know exactly what this means. And this is when you encounter an individual that you're having a hard time finding a make, model, and size that they can pass either a qualitative or quantitative respirator fit test on. And this is really where training comes in. And this is really where the competence and the confidence of the fit test operator is really going to be challenged and have to develop. So it's not complicated. I'll use our technology as an example on this talking point. If I'm utilizing either one of OHD's quantitative respirator fit testing devices and someone fails a test or a test step, there's a process that we can go through where we're inspecting the test subject, we're inspecting the respirator, we're inspecting our setup and our connections, our accessories to determine how can we address this hard to fit. And things that come up in these process, bang hair in the respirator. You can address that by getting the bang hair out of the respirator and getting good face to seal contact. Facial hair impeding the seal of the mask. That is not allowed in OSHA. The regulatory standard says that you must be clean shaving anywhere where the respirator seal touches the face. So fit testing someone with facial hair would not be advised, but people try it and then it's very, very difficult, if not impossible, to pass because the facial hair breaches the seal. So we're looking for bang hair, we're looking for facial hair. What else are we looking for? Did they don the respirator properly? Is it the right size respirator? Is there a potential integrity issue with that respirator? Are our components set up correctly? And do we have all of our connections set up properly? These are the things that you're looking to explore when you're into a hard to fit situation. One of the things that I love is OHD's built a little PDF poster that will walk someone through troubleshooting a respirator. And really it walks them through the things that we just discussed: checking the respirator, checking aspects of the test subject, checking aspects of the technology, just to make sure everything's in a good place. You know, if you have multiple sizes and you have the ability to troubleshoot, we're in a very confident place that we'll be able to find a make, model, and size that fits that person's face. But sometimes it takes a little bit more work and a little bit more exploration for some respirator wearers than others, and that's addressing the hard to fit. Rick, this might be a good spot just to kind of take a breath, see if there's any questions from the foundational stuff we talked about on fit testing and when we're talking about common challenges to fit testing.
Booth, at this stage, you are doing awesome with very few, without the questions coming through. So you are good to keep going.
I love it. Love it, love it. Hey, if I say anything that creates any type of confusion or question, again, just want to encourage those. All right. We've been building to this slide for some time during this presentation. We've referenced qualitative testing and quantitative testing numerously throughout the presentation already. Qualitative testing, you will see it abbreviated in the standards frequently as QLFT. Quantitative testing is going to be frequently abbreviated as QNFT. We've discussed this a little bit, but this is a great slide that kind of gives you the difference. Qualitative fit testing, the wearer of the respirator is going to detect the leak. It is a pass-fail criteria. So if the wearer tells you that they detect leak, then they fail. If the wearer of the respirator tells you that they do not detect leak, then they pass. And qualitative testing is almost always for half-face respirators, whether it's a elastomeric rubber seal half-face respirator or a FFR, which is a filtered face piece respirator, like an N95. Many people reference them as N95s. All right. Let me give a little detail on the wearer detects the leakage. Many of y'all probably are aware of this, but a qualitative test, we're going to dig into this in a second. You put the wearer dons their respirator, you put them in a hood, you squirt a solution in the hood, and they are determining the fit of that respirator based off if they smell the solution or taste the solution. And that's how the wearer is determining pass-fail. So that's qualitative testing. Quantitative testing is where you use an instrument, a machine, that uses a scientifically validated technology, and the machine is determining leakage and the fit of the respirator. The machine does not, the instrument and the technology does not operate off of pass-fail criteria. The quantitative instruments can provide you a numeric fit factor, and they can be used on any respirator. So qualitative respirator fit testing has some limitations. It is very rare to see someone qualitatively testing a full face respirator. It's an extremely rare scenario where you can do that. Most of the time when you're doing qualitative, you're testing a half mask, rubber seal, or an FFR. But if you're doing a quantitative technology, you can fit test any version of a respirator. All right, let's dig a little bit deeper into qualitative testing and into quantitative testing. We've set some good groundwork on that last slide. Subjective, pass-fail test that relies on the employee's response to an agent to detect leak. Currently, typical methods or You see the list there, but a lot of people will say it's the sweet or the sour solution. But those are your actual names of the different solutions that are utilized in the qualitative test. All right. Why does it say it's subjective? Simple. We're relying on a test subject's response. So there's some subjectivity to that. It's been scientifically proven that if Rick and I both do a qualitative test, and if we both get exposed to the same amount of the sweet or bitter sour solution, that we might respond to it differently, because that sweet, sour, bitter solution might not impact Rick as it does me. So there's some subjectiveness to it because we are relying on the wearer, the test subject's response, and it's been scientifically proven that test subjects can respond to the solutions differently. Another thing that's gotten very interesting with qualitative testing is COVID. Because what were some of the unique symptoms of COVID? People lost their smell and they lost their taste. Well, what does a qualitative test rely on? Smell and taste. So this is a little bit about the qualitative test. And again, here you're going to see a special note, only to be used for fit testing negative pressure air purifying respirators that requires a fit factor of 100 or less. Typically, that's going to be a half mask. All right. This is a good little image of a qualitative test in action. So you can see we have our wearer in the respirator in the hood. You can see our operator is administrating the sweet or sour solution into the hood, and our wearer is determining the fit of that respirator based off of smell and taste. What are some of the key highlights of qualitative test? It's inexpensive. It's low maintenance. There is no annual calibration required for a qualitative testing kit. What are some of the other things? It's imprecise. It's subjective. Subjects at times don't tell the truth. It's a slow, cumbersome process. So there are some gives and takes, some pros and cons to a qualitative test. All right, now let's switch to quantitative testing methods. If you look at the OSHA standard, and the OSHA standard is almost identical to all of your regulatory standards globally, there are two primary technologies that are recognized to do a quantitative respirator fit test. There is a technology called CNP, which stands for controlled negative pressure. And there is a technology called CNC, which stands for condensation nuclei counting. Many people refer to the CNC technology, they'll refer to it as ambient aerosol quantitative respirator fit testing. All right, OHD is uniquely positioned because we're the only company globally that manufactures a CNP quantitative respirator fit test instrument and a CNC quantitative respirator fit testing instrument. So we're the only company globally that can offer you an instrument that executes either of the OSHA recognized quantitative respirator fit testing technologies. All right, the CNP instrument is the OHD QuantiFit 2. It's going to be this guy that's to my left. What is the controlled negative pressure technology? This instrument's easy to explain. When this device is activated and the individual has the respirator donned, this device is going to evacuate the air out of the respirator, and it's going to put the respirator under a precise negative pressure. Now, if I'm wearing this respirator and we've got it connected to the QuantiFit 2, and the QuantiFit 2 is evacuating the air out of the respirator, and this respirator is under a precise negative pressure, the air outside of this respirator is going to naturally want to do one thing, and that is it's going to want to rush into the respirator. Here's the thought process. If this is the right size respirator for me, if I don this respirator properly, if I've got good face-to-seal contact, meaning no bang hair or facial hair that's impeding the mask, the seal of the mask, and if this mask is of good integrity, meaning there's no issue with the respirator, then we should be able to put this respirator under a precise negative pressure for a short period of time and identify very little air leaking into the respirator. On the contrary, if this is the wrong size, if I've donned it improperly, if there is something obstructing face-to-seal contact, or if there is an integrity issue with the respirator, then we're instantly going to start to find air penetrating the mask. All right. This instrument has two unique capabilities. The first unique capability you already know. It has the ability to evacuate the air out of the respirator and put the respirator under a precise negative pressure. The second unique capability of the QuantiFit 2 is it can tell you a direct measurement of leakage. It can tell you the exact amount of air that penetrates the respirator down to the CC. And what the instrument does is it collects that leak rate, the amount of air that penetrates the respirator when we've put it under that precise negative pressure. It generates a fit factor, determining whether we've got a good fit or not a good fit. That's the QuantiFit 2 using the controlled negative pressure technology. All right. The other technology that's written into the OSHA standard is the condensation nuclei counting technology. And that's going to be the OHD AeroFit, which is right here to my right. All right. The AeroFit uses the ambient aerosol condensation nuclei counting technology. Very simple to explain as well. This instrument has the ability to monitor a particle ratio in ambient air versus a particle ratio inside the respirator. And it will lead you through a testing process where it's constantly monitoring the particles out of the respirator versus particles in the respirator. And the way it determines the fit factor is by determining how many particles penetrate the respirator during the testing process. Obviously, if we have a good size respirator that's been donned properly, we've got good face-to-seal contact, and we've got a respirator of good integrity, there should be minimal particles penetrating the respirator during the fit testing procedures. If it's not the right size respirator, if it's donned improperly, if there's something obstructing face-to-seal contact, if there's an integrity issue, the ratio of particles will grow inside the respirator during the fit testing procedure and process, and that will lead to a poor fit factor and a possible failed fit test. All right, so that is the controlled negative pressure and condensation nuclei counting technologies. A brief description on both. Again, the QuantiFit 2, controlled negative pressure. The AeroFit is going to be your condensation nuclei counting. Now, let's dig in to these two technologies and instruments a little further. We don't really have to spend time on this slide because I've done some heavy lifting already to cover all this. So this is basically telling you how the QuantiFit 2 challenges a respirator using that controlled negative pressure technology. So we've covered this ground well, so we can keep on rolling. What are the advantages and limitations to the CNP controlled negative pressure instrument, the QuantiFit 2? The QuantiFit 2 and the controlled negative pressure technology does not require a testing environment. It is highly portable. It is known for doing the fastest, easiest, and one of the most accurate quantitative respirator fit tests that's currently recognized by your regulatory bodies. So it's a 5-step test that the system will lead you through. Each step is 8 seconds long. It does not require any consumables to run this device. It does not require a testing environment to run this device. Where we see the QuantiFit 2 and that controlled negative pressure technology thrive is typically in the health and safety, industrial hygiene, or first responder markets. Really anywhere where you're going to have predominant or exclusive use of respirators with rubber seals, elastomeric rubber seals. The QuantiFit 2 is typically the technology of preference due to the speed and due to the ease and due to the accuracy of this technology for testing respirators with elastomeric or rubber seals. Now let's talk about what is the limitation to the controlled negative pressure technology to the QuantiFit 2. All right, stick with me on this. I think y'all are all going to get this pretty simply. This instrument uses that technology where it's going to evacuate the air out of the respirator. It's going to put the respirator under precise negative pressure, and it's going to determine the fit of the respirator based off of how much air penetrates the mask. Now, I want you to think about doing that controlled negative pressure test to an N95 FFR type respirator. We're not going to be able to do it because we're going to pull air past this respirator every time. So the QuantiFit 2 has a limitation that it cannot test N95 mask. Okay? Again, if you're primarily, predominantly, or exclusively testing respirators with rubber seals, this technology really shines in those deployment methods. But if you're having a need to quantitatively test the N95s, that would really eliminate the CMP technology as being a great option. Okay? Now, let's keep rolling. Condensation nuclei counting. We've already covered everything on this slide. I did some great work earlier. What are the benefits of a CNC instrument? The AeroFit and the CNC technology can test all masks. So it can test N95 FFRs, it can test full face respirators with an elastomeric rubber seal, or it can test half face respirators with an elastomeric rubber seal. So the main benefit of this technology is it can test all masks. This technology really shines and thrives, especially in deployment methods where you're predominantly using or exclusively using FFRs and N95s. So I told you this one does well in health and safety, industrial hygiene, first responder. This instrument and technology has been the primary technology utilized in the healthcare industry. All right, limitations on the CNC technology. It does require a testing environment. It does require consumables. It's a longer test. If a test subject has eaten or smoked within 30 minutes of doing the test, they can have particulates in their lungs that mess with the technology's ability to accurately challenge the respirator. It's a more expensive technology. The annual calibration on this instrument is more expensive. So there's some limitations to the CNC technology, as there are some limitations to the controlled negative pressure technology. OHD and Lessman's endeavor is really to learn about your respiratory protection program and do all that we can to help you find your fit, to find which instrument and technology would best meet your needs. Some additional solutions that I'll reference really quick. I know we're up on time. And I would like you to just think back to some of the challenges that are out there with fit testing, because OHD has been diligent to find ways to address those challenges. One thing I'd like y'all to be aware of is we have a cloud-based software. The cloud-based software automatically schedules employees for their respirator fit test. That is going to directly address the scheduling and coordinating of respirator fit testing, which is a common challenge. AeroFit and QuantiFit 2 have user interfaces with animated instructions and written instructions. So if you'll remember, one of the challenges is adhering and accurately walking through the test process. Both of these instruments do a wonderful job of walking the operator and the test subject through the testing process properly. One of the common challenges was the annual maintenance and calibration of the quantitative instruments. We have prepaid calibration packages and extended warranties for these instruments that streamline that process in a wonderful way. Both of these instruments can store data on the instrument via a PC-based software or via a cloud-based software. So all of the record keeping and documentation you need is handled by the technology. And then the last thing is onboard troubleshooting. So everyone's aware that a hard to fit is one of the common challenges, and we've built in intelligence in these instruments that when a failure occurs, the instrument will actually provide some guidance on how to address that failure. So those are some additional solutions that are out there that were specifically generated to help address some of the common challenges. Rick, I'd love to hand it back over to you. I've got some time to go with questions, but I want to be respectful of everyone's time. I know we're up on time, but very much enjoyed providing the presentation and hope this helped with the different endeavors that are out there and respiratory protection programs that are out there.
Absolutely. I think you did a great job, Booth, and thank you. A few questions that we've got for you is regarding the daily calibrations and consumables. Can you go a little bit more into what consumables are needed and how frequently you need to calibrate? I'm not talking about the annual calibration, but throughout the year.
Yeah, great question, Rick. If you're using a quantitative respirator fit testing instrument, these instruments will require a daily verification. So you have your annual calibration and you have daily verifications, okay? Anytime you turn one of these instruments on, it's going to auto prompt you to complete a daily verification, which is a 1 minute, 2 minute process where the instrument does a self-check. You don't have to do that every day. You just do that any day you're going to utilize the instrument. And again, it will auto prompt you when you turn it on the first time that day to go through one of its daily checks. Regarding consumables, one of the advantages of the controlled negative pressure technology is there are no consumables. On the CNC front, the condensation nuclei counting technology, the AeroFit, there are some consumables. You're going to have a special isopropyl alcohol. The device has to have this isopropyl alcohol to properly run and count those particles out of the mask and in the mask. You're going to have some tubing. This tubing is important because it's how you're going to run the tube into the respirator to get your in-mask particle count. If you're testing N95 FFRs, you're going to have a little tackle box of push nuts and probes, which are the little push nuts and probes that allow you to probe the front of the respirator so we can test it. So there are some consumables on the CNC front. None of them are outrageous in cost, but they are consumables that you have to keep them, an eye on, as you're using that CNC technology.
Awesome. Regarding mask selection, we know there's a ton of different masks out there. What's involved in, the, user to, if someone's coming in with a new or a different mask, to be able to get that so that the system will recognize that mask?
Yeah, super simple. Great question, whoever had that. We've actually programmed every respirator that we're aware of on the global market, and we're very aware of the respirators because we have a phenomenal connection and relationship with every mask manufacturer, respirator manufacturer in the global market. So we program the respirators on these instruments. So when you are getting ready to do your fit testing, you just go into the library of respirators that we have programmed on the instruments, and you just activate whatever respirators you're going to be testing. And if you ever are no longer testing that make and model, you just go deactivate that and activate the new respirator that you're going to be testing. So it's very, very simple through these instruments and through the software that these instruments utilize to make sure that you're accessing the respirators that you're going to be testing.
Awesome. I just received a question. I'm going to just read it verbatim because I don't want to miss anything here.
Yeah.
Um, on the instrument comparison slide, one of the units had a note that the setup replaces the filters on the respirator to perform the test. Would you then potentially need a number of different adapters to accommodate a variety of different respirator cartridges and their shape sizes, i.e. North, 3M, GBS, etc.?
It's a great question. So when you're testing with the controlled negative pressure technology, you actually will not have any kind of respirator manufacturer filter on the mask. You would simply replace the filters with OHD adapters. So this is the 3M quarter turn adapter. So any 3M respirator that uses a quarter turn connect, we have an adapter that will connect with all of those respirators. So that's how the controlled negative pressure technology works. You don't use a filter, you just connect up our adapters. If you're using the CNC technology, then you do use the manufacturer's P100 filter and a fit test adapter. So you would have, if we were testing this respirator with the AeroFit, you would have an OHD adapter with the P100 filter on this side, and then just a P100 filter on this side. So AeroFit, you're using the manufacturer's P100 filters. QuantiFit, you're not using filters, you're just connecting adapters. Sometimes when people hear this, they think that there's like millions of adapters OHD makes. That's not the case. We test all of your 3M masks with 2 different adapters. We test all of your MSA masks with 2 different adapters. We test most of your fire and first responder masks with 1 adapter. So there's not actually that many adapters out there. It's basically an adapter per manufacturer.
Awesome. James, if that answered your question, great. If not, feel free to respond for anything more specific. An interesting question also is, can these systems test in environments where aerosols are restricted, such as clean rooms, healthcare areas, nuclear areas, and so forth?
This instrument has 0 environmental dependency. You can test indoors, outdoors, clean room, room with lots of particles in the air, can test anywhere. This instrument requires a testing environment, okay? It is heavily used in the healthcare market, which that is a lot of times clean area, very clean air. And the way that this system addresses that situation, you may not be able to see it well, but we have a particle generator right here that's actually hardwired connected to the fit testing instrument. And this fit testing instrument, when it's on and when it's doing its daily verification and when it's executing a quantitative respirator fit test, it actually drives this particle generator, and it will create a testing environment even in those clean areas with just bottled water, tap water, gives us enough of an environment to test. But we have a specific, very unique way to ensure that we have the proper environment to do tests in those clean environments in healthcare and the other things that were referenced there.
Awesome. The last thing that I've got here is talking a little bit about warranty and technical support for companies that are out there using this stuff and need support.
Love it. The instruments come with a standard 2-year warranty. The majority of people who purchase fit testing instruments through Lessman and OHD will purchase a prepaid calibration package with the unit. We referenced that very quickly when we were talking about additional solutions. And those prepaid maintenance and calibration packages not only streamline that annual calibration and maintenance process, but there's a ton of cost savings and convenience included in those. And one of the really special things about those prepaid calibration and maintenance programs is they extend the warranty out, and we offer a 3-year prepaid maintenance and calibration package. We offer a 5-year prepaid maintenance and calibration package, and we also offer a 10-year prepaid maintenance and calibration package. And if you buy the 10-year prepaid maintenance and calibration package, you get 10 years of extended warranty. So it comes with a standard 2-year warranty, but you can extend that out to 3 years, 5 years, or 10 years based off of purchasing a certain prepaid calibration package that would also extend the warranties on the devices. There was another question in there. What was the second part of that question?
Technical support.
Oh, technical support. OHD grades out phenomenal from our tech support perspective. It is Monday through Friday from 8 to 5 Central Standard Time. We are exploring adding some additional hours to really make sure we can cover the West Coast of the U.S. well. We have a tech support branch and office in Europe that manages all of our European clients. But tech support is something that we are intentional to offer and have a major desire to serve our customer base as they endeavor to manage their respiratory protection programs with our technology.
Awesome. I don't have any more questions. First of all, Booth, we just really appreciate you taking the time to give this really informative presentation. I want to make it clear to anyone, if you have any specific application questions, my contact information is currently on the screen, and feel free to reach out to me at any time. And I'm always happy to, if it's a technical question, to put a team call together and Booth and I can answer your questions directly. If there's anything else you'd like to know about other technologies we support, all of our webinars, including this one, are posted on our website at lessman.com, and we post it on Lessman Instrument Company YouTube channel. And finally, if there are any additional topics you'd like us to cover in our webinars, please send me an email with the subject. We have access to a lot of different products and process specialists, so please let me know if there's anything that you would like to see covered by emailing me at the rickd@lessman.com address. And at this point, I don't see any other questions, so I will go ahead and conclude it. Thanks again, Booth.
Thank you, Rick. Really enjoyed partnering. Hope everybody benefited from the presentation and eager to help if I can.
Awesome.